Now I'm going to find the area of a regular heptagon. So a heptagon has 7 sides. So I know that I need to find N, B, and H. So N is going to be 7. Now this time, I don't know what my height is in my triangle. So here I just drew this isosceles triangle bigger so that I could have a little more space for my work. I don't know what the height is, but now I do know what the base is. So the base is 14. The height is what I'm going to be trying to find. My first step is to find my central angle. Central angle is going to be 360 degrees divided by 7 because it's a heptagon. And I will tell you right now, you're going to have a decimal, but that's okay. Decimals are all right too. So 360 degrees divided by 7, that is approximately 51.429, but that is this entire angle. And I only want to find half of it. I want to find that angle because that angle is going to be the reference angle for this right triangle that I just highlighted here. So now that I know 51.429, now I'm going to cut it in half so that my theta, my reference angle, will be 25.714. All right, so that is this angle right here is 25.714 degrees. I'm looking to find my height. My height is the adjacent leg. And the opposite leg is over here. And that opposite leg is always going to be half of the side length. So if my side length is 14, this leg is going to be 7. Okay, so this is the opposite leg, 7. The adjacent leg is H. I don't know what it is yet. My reference angle is 25.714. So now I'm going to use that right triangle trig. So since I have opposite and adjacent, I'm going to use tangent. The tangent of 25.714 degrees is equal to the opposite leg, which is 7, divided by the adjacent leg, which is my variable h. When your variable is in the denominator for these trig ratio problems, when it's in the denominator, I showed you guys the math behind it, how you can multiply both sides by h, divide both sides by the tangent of your reference angle. But essentially what it boils down to is switching the place of the tangent of my reference angle and h. So that means that I would now have h equals 7 divided by the tangent of 25.714 degrees. Okay, so that's what I'm going to put into my calculator. 7 divided by the tangent of 25.714. And I get that my height is 14.5358, so I'll round it to 536. All right, that's what I needed. I needed to find my height. So now I know my height is 14.536. So now I can plug that into my formula to find the area of my heptagon. So the area of my heptagon is going to equal n, which in this case is 7, times b, which in this case is 14, that's the side length, times h, that's what we just found using right triangle trig, 14.536, divided by 2. So now I can put this into my calculator. 7 times 14 times 14.536 divided by 2. And I get that the area equals 712.264. And again, I don't have units, so I'll just call it units squared. You can use this process for any regular polygon, no matter how many sides it has. You just need to find n, which is the number of sides, b, which is the base of one of the isosceles triangles. Also, it is the side of your polygon, and h, which is the height of your isosceles triangle, which goes from the center of your polygon down to the side of the polygon. So it doesn't matter what size your polygon is, how many sides it has, you can always use this process.